What if the sky turned black, not from the setting sun, but from something far worse? What if a single moment, no longer than a heartbeat, could erase entire continents, vaporize oceans, and plunge the world into centuries of darkness? This isn't the plot of a sci-fi thriller. It already happened, and it could happen again. 66 million years ago, Earth had its worst day. A day so violent, so final, that it nearly ended life itself. A massive asteroid, traveling faster than anything we could imagine, struck the Earth with the energy of 10 billion atomic bombs. The sky burned, the oceans boiled, and 3/4 of all species vanished into ash. But it wasn't the end. A few survivors, hidden in the shadows, clinging to life in the chaos, would eventually become the ancestors of every living creature on Earth today, including us. But here's the question that haunts every scientist who looks to the stars. If it happened again, would we survive? 66 million years ago, long before humans existed, before cities, before civilization, the Earth awoke to the worst day in the history of life. A rock larger than Mount Everest was hurtling toward our planet at more than 20 kilometers per second. That's over 72,000 kilometers per hour, 60 times faster than a jet airliner. It had no warning, no mercy, and no conscience. It came from deep space, moving with the silent inevitability of fate. It entered the atmosphere at a steep angle from the south. In the final seconds of its descent, it compressed the air in front of it so violently that the atmosphere itself ignited. A trail of fire carved across the sky, bright enough to be seen from the far side of the planet. Then, impact. The asteroid struck near what is now the Yucatan Peninsula in Mexico. In that instant, 100 trillion tons of rock and seawater exploded outward. The energy released was more than 10 billion times that of the atomic bomb dropped on Hiroshima. The ground liquefied beneath it. The sky was torn open. A fireball expanded faster than the speed of sound, vaporizing everything in a radius of hundreds of kilometers. Even before the shock wave hit, entire forests had already turned to ash. Creatures never saw it coming. There was no time to run, no place to hide. The ocean was blasted away, replaced by a temporary crater more than 30 kilometers deep. And above it, molten debris, now part atmosphere, part asteroid, part Earth itself, was launched into space. But gravity brought it back down in a storm of fire. All across the planet, the sky began to rain. But this was no ordinary rain. These were droplets of glowing rock falling at terminal velocity. The air became a furnace. For 20 full minutes, the surface of the Earth grew hotter than the inside of a pizza oven. It was enough to ignite trees, grasslands, and entire continents into simultaneous wildfires. The dinosaurs were not wiped out in a single blow. But this was the first and most brutal of many. The day the sky fell was only the beginning. The asteroid's impact didn't just scorch the Earth, it cracked it open. Shock waves surged through the planet's crust, racing faster than sound, bouncing between tectonic plates, triggering an earthquake in every corner of the globe. Some scientists believe these quakes reached magnitudes as high as 11 far beyond anything humanity has ever recorded. But the ground didn't stop shaking. In some regions, it shook for hours. In the Indian subcontinent, massive volcanic fields known as the Deccan Traps erupted violently. For tens of thousands of years, they had been slowly leaking lava. But now, jolted by the impact, they exploded into life. Molten rock gushed from the earth like blood from a wound, covering entire landscapes in thick black flows. But even this lava earthquake's fire wasn't the final blow. As the dust of destruction rose into the sky, the atmosphere itself began to change. Trillions of tons of ash, vaporized rock, and sulfur were blasted upward, past the clouds, past the stratosphere into the mesosphere. And then the light began to fade. Within days, the sun vanished behind a planetary shroud. The sky was no longer blue. It turned brown, then gray, then pitch black. For weeks, months, possibly years, sunlight could not reach the Earth's surface. Global temperatures plummeted. Photosynthesis stopped. Plants died. The herbivores starved. The carnivores followed. But the darkness wasn't silent. Across the charred wastelands, wildfires raged, fueled by oxygen and debris still falling from the sky. Acid rain began to fall, mixing with atmospheric chemicals, seeping into lakes, rivers, and oceans. Ecosystems collapsed. The air became toxic. The seas turned acidic. Life was under siege from every direction. Imagine a planet where every morning is night, where no crops grow, where the stars are hidden, where even time itself seems to freeze. That was Earth after the impact, a world without a future. After the fire and the darkness, Earth was quiet. The roars of volcanoes faded. The rain slowed. The skies remained black, but the initial violence had passed. What followed was something more terrifying: silence. 3 out of every 4 species on the planet were gone. Entire branches of the tree of life had been snapped off. From the towering Tyrannosaurus to the smallest flying reptiles, the age of dinosaurs had ended. But not everything had died. In the rivers, crocodiles floated silently, barely moving. Their cold-blooded metabolism, honed over millions of years, allowed them to survive without food for months. While the world above burned, they waited below, feeding off dead animals washed downstream. On the land, birds, or at least some of them, persisted. The ones with teeth dependent on meat perished, but the ones with beaks survived. Why seeds? Seeds don't rot easily. They don't need sunlight to stay edible. Birds with beaks could crack into these tiny time capsules of life and feed on what others couldn't. But perhaps the most important survivors were small, furry, and easily overlooked. Mammals. Tiny, shrew-like creatures that had spent the dinosaur era hiding. Hiding from predators. Hiding from daylight. Hiding from danger. When the asteroid struck, that hiding instinct became a superpower. They burrowed. They dug deep. They nestled in underground pockets where the heat and fire couldn't reach them. They scurried through tunnels, feeding on fungi, insects, anything still living. And slowly, cautiously, they emerged. Generation after generation, they adapted, grew, changed. These small, fearful creatures, no bigger than a hand, would go on to become primates. And eventually, us. We are not descended from the kings of the earth. We are descended from the survivors. the quiet ones, the shadow dwellers, and in that truth, there is a lesson. Survival favors not the strong, not the brave, but the adaptable. We now know what a mass extinction looks like. We've seen the aftermath. But what if that very same asteroid returned same size, same speed, same trajectory, same impact site, the Yucatan Peninsula? Only this time, we're the dominant species, and we have far more to lose. In the first few seconds of impact, Central America and the southern United States would vanish in a flash, vaporized by heat and shock. Over 100 million people would die instantly, not from fire, but from energy. The blast wave alone would flatten cities as far as 2,000 kilometers away. Buildings would crumble like dust. Roads would rupture. Power grids would fall. And then, the sound would arrive. A noise louder than anything ever heard, more than 300 decibels. So intense it wouldn't just rupture eardrums, it would rupture organs. Anyone within the 500 kilometers would be killed, not by fire or falling debris, but by pure pressure. Across the planet within minutes, Earth would begin to shake. Magnitude 9 to 11. Earthquakes would ripple around the globe, the kind of shaking that splits cities in two breaks, dams, and tears open the crust. But the sea would rise with fury. Massive tsunamis, 100 meters tall, would tear across the oceans, smashing into coastlines and flooding them for over 100 kilometers inland. Ports, coastal megacities, entire island nations gone. In the first hours alone, more than 3 billion people could be at risk of drowning. And that's still not the end. The debris cloud launched by the impact would circle the globe in hours and begin to fall, not as rock, but as fire. Molten fragments would rain from the sky, igniting forests, burning cities, and setting off a chain reaction of wildfires across continents. It would be apocalypse by speed, fire, water, and pressure. In a world of satellites and cell towers, we like to believe we're prepared for anything. But there are no apps for this. No live tweets. No emergency push notifications that could save you from the speed of an asteroid. By the time we saw the flash, it would already be too late. And the question isn't just, would we survive? It's this: could we even respond in time? If an asteroid like the one that ended the age of dinosaurs struck today, our first instinct wouldn't be to fight. It would be to hide. But where could nearly 8 billion people go? There would be no time to evacuate the entire Earth. But in the chaos of the first hours, a global race would begin, not across borders, but beneath our feet. Millions would flee toward underground shelters. Some countries are better prepared than others. Switzerland, for example, has built enough fallout shelters to house its entire population. Its mountains are riddled with reinforced bunkers stocked with water, food, and air filtration systems. In Iran, the ancient underground city of Nushabad still stands, a maze of cool tunnels built to escape past invaders, now perhaps ready for a new kind of siege. In Turkey, Derinkuyu stretches more than 60 meters below the surface, an entire city carved from volcanic rock thousands of years ago, complete with stables, wells, churches, and air shafts. Across the modern world, abandoned mines, subway systems, and military bunkers could all be repurposed as makeshift sanctuaries. The New York subway alone spans over 1,000 kilometers. In theory, enough space exists to shelter billions, but only if they could reach it in time. And time would be the one thing in short supply. For those close to the impact zone, there would be no escape. For those farther away, survival would depend on one question: how fast can you get underground? But even the deepest shelters weren't built for eternity. Most are designed for weeks, a few for months, very few for years. They lack agriculture. They lack sustainable energy. They lack community structures. And most of all, they lack hope. There are exceptions. The Raven Rock Mountain Complex in Pennsylvania, a U.S. government facility buried deep in a mountain, is believed to contain multiple underground levels. Freshwater reserves its own power grid and space for thousands, but details are classified, and access reserved for the few. Meanwhile, the ultra-rich have been quietly preparing luxury bunkers. In New Zealand, complete with indoor gardens, filtered air, and digital infrastructure, have already been built beneath the rolling hills. Some even feature years of supplies and private security, the hope to wait it out. But hiding is not the same as surviving, because after the blast comes the long winter. And no bunker, no matter how deep or how luxurious, can hold out forever. After the fire, the earthquakes, and the flood came silence once more. But this silence was not peace. It was the sound of a world beginning to starve. As the dust from the impact continued to shroud the planet, sunlight was nowhere to be seen. For months, even years, the skies remained dim. Temperatures dropped. Crops failed on a global scale. Fields that once fed billions turned to lifeless dirt. And the food we had stored, it began to rot or run out. The global food supply chain, already fragile, completely collapsed. No planes, no ships, no trucks. Nothing moved. What was local was all that existed, and for many that meant nothing. Water, too, became a curse. The rain that fell was acidic, poisoned by sulfur and nitric acid from the skies. Rivers and lakes turned toxic. Fresh water had to be rationed, purified, if it could be found at all. Then came disease. In crowded shelters with limited resources, viruses spread like wildfire. Basic healthcare vaccines, antibiotics, even bandages became luxuries. But none of these killed more than hunger. Famine became the great equalizer. In rich countries, and poor in bunkers, and in cities, people began to fade. Quietly, slowly, desperately. And yet, somewhere in the dark, life tried. Mushrooms grew in the damp, oxygen-rich tunnels. Fungi don't need sunlight. They thrive in death, in decay. After wildfires and devastation, fungi often flourish, and in a cruel twist of nature, became one of the few surviving food sources. Elsewhere, algae tanks were built. These microscopic organisms can survive in low light and reproduce quickly. Not delicious, but life-saving. Algae might not offer comfort, but it offered calories. Still, the survivors were ghosts of what had once been humanity. no global communication, no electricity in most places, no internet, no cities buzzing with light, just small pockets of people surviving by instinct rationing, repurposing, and waiting. Waiting for the skies to clear, waiting for the sun to return, waiting for the earth to remember how to breathe. But for many, the wait would be too long. Because this wasn't extinction by explosion. It was extinction by exhaustion. Not the loudest end, but the slowest. It's a terrifying thought that everything we've built could vanish in a flash of light from the sky. But what if we didn't have to just wait for the end? What if we could stop it? In September 2022, humanity took its first real shot at doing just that. NASA's DART mission. The double asteroid redirection test intentionally crashed a spacecraft into a tiny asteroid 11 million kilometers from Earth. And it worked. The impact slowed the asteroid's orbit by 32 minutes, enough to prove that we can in fact change the path of a space rock hurtling through the void. It was a historic moment. For the first time in the history of life on Earth, one species proved it could defend its planet from the very kind of threat that once ended the age of dinosaurs. But there's a catch. The asteroid DART hit was small, just 160 meters across. The one that wiped out the dinosaurs was over 10 kilometers wide, 60 times larger, more massive than Mount Everest. Stopping something like that is an entirely different problem. Blowing it up sounds cinematic, but it's dangerous. If we detonate a large bomb on or near an asteroid, we risk turning one big rock into dozens of smaller ones, all still deadly. Other ideas include using nuclear explosions to push it off course, or attaching thrusters to change its trajectory gently. Some propose painting the asteroid white so solar radiation pushes it slightly over time. Others dream of attaching giant solar sails, lasers, kinetic strikes, gravity tractors. The ideas are growing, but the window for action is small. For asteroids from inside our solar system, we now have pretty good maps. Astronomers have tracked over 90% of objects larger than 1 kilometer, and so far, none are on a collision course. But not all threats come from within. The real danger may be interstellar asteroids or comets coming from outside the solar system at unimaginable speeds. These rogue objects could arrive with little to no warning, traveling so fast that even the best telescopes might see them only weeks or days before impact. In such a scenario, all our ideas would become wishes. We wouldn't have a deflection plan. We'd need a survival plan. The truth is, we're not defenseless, but we are unprepared. And in a universe full of moving rocks, luck is not a strategy. If stopping an asteroid isn't guaranteed, then we're left with one option: survive the aftermath. If we had months or even years of warning before a collision, humanity might stand a chance. A final chance to build to plan and to escape the surface before fire falls again. Our first move: evacuate the blast zone, the Yucatan Peninsula, Central America, the southern United States. Save what we can, while we can. Then dig, fast and deep. Across the world, mines, subways, and caves could be transformed into underground cities, shielded from impact fire and fallout. These new cities wouldn't be sprawling metropolises. They'd be bunkers, functional, self-sufficient, brutal, but alive. Energy would come from the Earth itself. In Iceland, for instance, geothermal power could keep critical systems running: heating, lights, water purification, without relying on the sun. Water would need to be preserved, hidden from acid rain. Deep silos lined with acid-resistant material could store millions of gallons, sealed, tightly guarded like treasure. Food would be a daily battle. With the sun gone, traditional farming would fail. But vertical agriculture could rise. Mushrooms, algae, and lab-grown nutrients might feed a new generation born beneath concrete ceilings. And not just food, but the seeds of the old world must be kept alive. Biodiversity vaults, DNA archives, libraries of knowledge encrypted and distributed, human embryos, frozen in time, vaults placed deep in mountains under permafrost across continents. Guardians of the past waiting for a future that may never come. But for some, even that wouldn't be enough. What if we left? What if, while Earth burned, a small colony stood watching from afar? A group of scientists, children, engineers, artists launched to the moon or Mars, or some orbital outpost to carry the torch of humanity forward. The moon offers harsh conditions, but also safety. No atmosphere means no impact shockwave, no acid rain, no wildfires. From there, they could observe Earth. Wait, hope. Hope that one day the skies would clear, that the fires would stop, that green would return, that they could go home. Because in the end, this isn't just a story of disaster. It's a story of memory, of resilience, of the human will to preserve beauty even in ruin. We've lived through extinctions before. We're the legacy of those who hid, who crawled, who endured. And if that day ever comes again, when the sky turns to fire, maybe we will survive, not just through strength, but through foresight, because the future will not belong to the fearless. It will belong to the prepared.